One of my favorite stories in the past decade of digital mapping history is that of Google Maps. In 2004, Google acquires this small startup named Keyhole. A lot of the core team ends up building what becomes Google Maps and Google Earth as part of this giant moonshot project inside Google in the late 2000s. We now take these things completely for granted, but I found the story behind them fascinating. Actually, fast forward a few years, and a lot of the same team behind this feat ended up working at Niantic, which you might also have heard of because they made the hugely popular Pokemon Go app. I mention this because my guest today is Brian McClendon, one of the earliest investors and then VP of Engineering at Keyhole in the early 2000s. He then went on to work at Google for over a decade, leading pretty much all of Google's geospatial and mapping efforts, then did a few years at Uber, and is now at Niantic, building the future of augmented reality. This conversation was pretty cool, I have to admit. We touched on the story behind some of the most successful mapping and geospatial projects pretty much ever, and what comes after. This episode is sponsored by OpenCage. If you're building any application or tool that uses location data, at some point you'll probably need to convert place names or addresses into coordinates, or coordinates back into place names. And this is where OpenCage comes in. They offer a worldwide, affordable, forward and reverse geocoding service that's easy to use. OpenCage builds on top of open data sources, which grants much more lenient licensing terms than alternatives like Google, allowing you to store the data as you want and even keep it after you stop being a customer. You can also display it on any map, all at a more affordable price. OpenCage handles all the complexity of dealing with the messiness of the real world and provides a simple-to-use API that allows you to focus on your use case. They have a generous free trial that you can use to get started with no credit card required, and they offer a clear upfront pricing with a cancel at any time, no questions asked policy. To learn more, head over to opencagedata.com. I'll have a link in the show notes. As a side note, OpenCage is also responsible for hosting the GeoMob events as well as the GeoMob podcast, for which I'll also have links in the show notes. Thank you to OpenCage for once again being a sponsor and for their continuous support of the podcast. The way I like starting these conversations is I like asking people how they would describe themselves. You're someone that's done a lot of different stuff throughout your career and throughout your life. And so just a very simple but very open question. How would you describe yourself?
A computer nerd. I grew up in the era of early personal computers and started getting involved with them when computer graphics was young. And I loved computer graphics. I ended up being an electrical engineer, ended up building computers, and I've just been around them my whole life. And I believe they can enable new things, and starting with 3D graphics, but ending up sort of in maps.
How did you get into computing, and then specifically computer graphics, especially so early on? Now it's a huge thing, but it wasn't when you got into it.
No, I mean the games that I started with were black and white Space Invaders and vector graphics Asteroids, and then Pac-Man and Ms. Pac-Man Missile Command. So these were the original arcade games that I spent plenty of quarters on and really enjoyed and would love to have brought into my home, but of course the home computers of the day couldn't render those kind of graphics, at speed. And so I was, the Atari 400 was my first computer. And, I learned basic writing on that computer, more or less, and started doing graphics programming, mostly for fun with these games until my senior year in college, when I ended up doing some work on a sort of real graphics computer.
What do you mean by real graphics computer?
Well, it's one that nobody's heard of. It was called a Megatech. Think of it as like a Intergraph for Silicon Graphics that was just not as good. But it was a high-end, vector rendering 3D graphics pipeline, and so figuring out how to get that hardware to work at all was pretty much a miracle. But it taught me a lot about what the current state of graphics APIs were at the time, and it was turned out to be a perfect lead into my next 10 years.
How did you go from that to deciding? Because you've also been involved a lot in starting companies and in helping managing companies on boards. How do you go from the technical side to deciding to get involved on the company level, not just as an individual contributor, as just an engineer, but also getting your hands dirty on building the companies that create some of these tech?
That would have been around 1996 at the end of my Silicon Graphics time. Many of my friends went to different companies. They went to companies like TiVo and Netscape and Shutterfly and a bunch of other companies that were just getting started. One company that happened right after that was called Gigapixel. And that was, I helped start the engineering team for that as a side job, and work with some friends to build that company into was arguably the best graphic startup of its era. It got bought by 3DFX at exactly the wrong time, but it taught me a lot about both creating companies and the risks on how companies exit and how much to depend on single customers.
Is that something where you got burnt and then you wanted to get a bit more involved yourself?
I didn't get burned personally as much because I helped them start and I put money in and I actually got money out.
Okay.
But the company as a whole did get burned. They were effectively used as a stalking horse by Microsoft for the Xbox. So they were given the Xbox contract, but it was really a negotiating technique to get NVIDIA to lower their prices. And so Microsoft, paid a chunk of money, but then just dropped them on the floor after they had already sort of committed to that business plan, and they couldn't come out of that hole.
That's something I'm guessing, like, you see that, and does that make you want to get involved yourself in, like, on the business aspect, making sure that if you
Yeah,
build that
it got me
technology?
closer. I spent time with the CEO of that company. While I was helping Gigapixel start, I had joined a something that was called a startup, at home network, but we were about 80 people at the time, but we were already sort of acting like a big company. So I didn't feel like I learned a lot about startups there, but it was very much an internet company, and it was very much part of the dot-com boom, and it IPO'd in 97 and did well for a while. But it was a tease. And, I very soon decided I did not like that sort of big company itis in a small company, and went to start a small company with three friends called Intrinsic Graphics. And that was Michael Jones, Remy Arnaud, and Chris Tanner.
And if I understood correctly, that's also where Keyhole starts, kind of as an internal project on the side.
That is correct. Our first demo, and the demo that raised money for Intrinsic Graphics, was this 3D EarthViewer that ran on a PC and was performant. It was good quality, good texture, 3D 60 hertz, and that helped sell the idea that a software layer in graphics could actually make things go faster.
I'd love to understand a little bit more about what you are thinking at that time. Like, what is the goal of building Intrinsic Graphics? What are you guys trying to do? You start this company. What's the goal of the company, and what are you trying to achieve at that point?
Well, to rewind a bit, at Silicon Graphics, a team sitting right next to us that was composed of people that I worked with built the Nintendo 64 graphics chip and effectively the CPU, because it was a MIPS CPU. So we learned a lot about game platform hardware by sitting next to them, and eventually becoming addicted to Super Mario 64 across the entire group. But we realized that programming, we had come from Silicon Graphics, where we had a standard API called OpenGL that allowed for high performance 3D graphics and was portable to other companies and other machines. The games did not have that. There was no way to sort of consistently develop between a Nintendo 64 and a PlayStation 2 and Xbox didn't quite exist then. It just started a couple years later. And so we saw this game development was quite difficult, and it had several dimensions to it. We were very focused on how do you solve the computer graphics part of the problem, and so we thought we could build a game development platform that made computer graphics fast on all of those platforms and allowed you to develop on a PC while producing code that would also run on the various boxes of the day. And I would say that the four of us, were not deeply educated in game development culture. And at the time, game developers loved to write to the hardware. Everything. If they weren't writing, assembly and bit twiddling, they did not feel like they were doing their job. And so the idea of an abstraction layer was a tough sell. And I think we timed it not perfectly, but we certainly gave us enough time to build out our suite of both 3D graphics and game development that by the time developers began to realize that scaling game development was harder, we had built out enough that several games were built on that stack, and it was eventually bought by Activision, and then now is owned by Microsoft and is still in use today.
If I understand correctly, you were effectively trying to build what we refer today as game engines, basically something like a Unity, where you need to learn Unity and then you don't need to worry about is it going to be even played on a phone today or on a PS5 or on PC, and just have people focus on creating the assets and the game code, but not hardware. But that was too early.
Yes. We were Unity 15 years too early. And I think the challenges were, we were a little bit too computer graphics focused, and the game content assets like the 3D modeling. One of the things we eventually or quickly had to learn was that 3D Studio Max and Maya were important game tools for the artists to build the content, and then they wanted to see how does this content play on the machine in the game, and so having a very easy development experimentation flow from artist to in-game was critical. Unity certainly has figured this out at this point. They're deeply integrated with the art tools, but at the time, I think we had started out with this delusion that just fast 3D graphics and portability was all we needed, and physics and a bunch of other aspects of game engines are also very useful, and so we eventually had to integrate and learn how to use those.
You have all this technology, and then there's a demo that gets started with EarthViewer using a lot of the same tech. It starts out as a demo originally.
The first version of the demo was running in late 98, and we continued to build on it throughout 99. And at the end of 99, the VCs who had invested in Intrinsic said, you need to spin this out. This is sort of not intrinsic graphics, it's something else. So we decided to hire a CEO and let that CEO go look for funding separately from Intrinsic, and basically split the company into the EarthViewer demo / product, and then keep Intrinsic graphics on the path that the game engines and so forth. And that CEO is John Henke, and he had just finished working on a game called Meridian 59, and also just got his MBA from Haas, and so he was very interested in the area, and it was not a hard sell for him at all. And he took on the need to raise money, and successfully raised money, and got Keyhole started up as a separate company.
Yeah, I've been reading Bill Kilday's book kind of ahead of talking together, that kind of maps, pun intended, a lot of the story of what happened. And it's been interesting to see how many times, at least from how Bill mentions it, Keyhole barely made it and then went back up, and then barely made it and went back up. And what I'd love to hear is kind of before it explodes into this massive things with Google Earth and Google Maps, and I'm sure we'll get to it. I'm just really curious, what does it feel like when you're in the middle and you kind of don't really know where a project like this is going? Like, you feel like there's a demo and you show it to everybody, and everybody that sees it is like blown away. But there's this moment where it's hard to get people to figure out the business model behind something like that. And looking back, you can see the story and there's the hindsight, but I always wonder, when you're in the middle of that, it's days and weeks and months that go by, and kind of how do you feel in that moment?
It was a very complicated time. We were coming out of the dot-com boom, which was a situation where you didn't need to show money coming in. You just needed to show usage. If you had the users, the money would come later was a completely valid business model in 2000 or 1999. In 2001 and 2, it was not. So that was a very sort of tough jump, because a lot of people saw this and believed that we would get users. But the question is, who would pay for it? But in general, I would say, being in a startup in 2001, 2, or actually any time, is sort of a terrifying experience. You as a leader have sold these people that you've asked to join the company on this idea and vision, and you've convinced them that there's gold at the end of the rainbow, but there's not a clear path, and you have to come up with the ideas that either generate revenue or raise more money, or you die. And a lot of companies in 2002 died. It was just brutal. I mean, many companies who should never have been funded correctly died in 2001 and 2 and 3. But Keyhole survived. We as a company were initially targeting this idea of being Earth.com. And .com, the Earth domain, the domain, was owned by somebody. We were going to buy it, but that never worked out. But the idea of a consumer app. Well, in 2002, we realized you have to get revenue, and consumers don't pay out of pocket quickly or in volume, so go to enterprise. And the two verticals that resonated most, based on all the talking we've done with people, were going to be around real estate and travel. And so we, successfully built a business, probably a tiny bit like Matterport is today, where the real estate agents adopted our tech to help show the property in a better light, and so they would pay $600 a year for the subscription. And they were able to generate, printouts that they could, share as collateral. Because back in the day, it was online. Real estate was not really there, but this was a big add value for them. And then travel agents being able to show properties, show what it was like when you get there, was another area that I think did very well. That and enterprise use cases where people had data, their own data they wanted to show. Caused us to build out a enterprise suite called Google Earth Enterprise. Called Keyhole Enterprise.
That came after.
Yeah. And so that kept us alive. And in 2002, I think, Bill describes in his book, we as a company struggled to make ends meet. And John successfully worked with the employees to reduce salaries in exchange for stock, so that the company could continue. And we also eventually did a deal with NVIDIA to offer a consumer version, because NVIDIA realized it would help sell their graphics cards. So if you bought an NVIDIA graphics card, you could get a low-cost subscription. I think it was $79 at the time. And that was a very big step. So after the deal with NVIDIA, we also had done a deal with CNN. It turns out that a junior high school friend of mine was now the CTO of CNN. And I met him at the National Association of Broadcasters meeting, and he got excited about using Keyhole and actually did a deal to pay us to use Keyhole on air and include our logo on the screen as part of the deal. So, we gave him a good price, but it was actually a good enterprise deal for us as well. But we got branding on the screen every time they used Keyhole to sort of talk about a news story. And in early 2003, the US invaded Iraq, and suddenly everybody was watching CNN all the time. And CNN was using Keyhole to show what was going on in Iraq, for sometimes minutes at a time. One of the broadcasters, Miles O'Brien, had 5 or 10 minute sessions where he would just use Keyhole and talk about things in the images and zoom in and out and jump to different places. And so everybody saw this and immediately said, "Hey, does this work on my computer?" And we got more downloads than we knew what to do with. It was an incredible time. Our servers, which were in a sort of a dungeon downstairs in a Palo Alto basement, uh, got severely overloaded, and it would take minutes for it, sometimes the data to download. But people didn't care. It worked eventually, and once it was in your cache, you could see it again. So that in many ways saved the company, because we sold a lot of subscriptions, and the awareness about the product basically grew 100 or even 1,000-fold.
Can you take me back to that time? What made Keyhole, so like the EarthViewer, so different from what existed back then? And then maybe at a high level, technically, how did it work?
The biggest thing that was different about Keyhole was it allowed you to have context. Many people could show a static satellite image and say, here's this picture, but you couldn't zoom out and put it in the context of the country or the planet or even the city if you were zoomed in. And so this ability to say, here's what you're looking at, and if we zoom out, here's where you are in the world, and be able to do that arbitrarily for any place, was a very powerful storytelling technique, so that CNN, immediately gravitated towards and used very heavily. At the time, maps did not zoom. I think there was, MapQuest would allow you to type in your address, and their servers would literally go off and render and create this 512 by 256 image map, and it would take 20 seconds. And if you said zoom, it would take another 20 seconds. And so this feeling of being able to go where you wanted to and have at least some idea of the context, whether it was just in the Keyhole case where we were drawing the borders in vector form with the satellite under it. So even if the satellite imagery wasn't sharp, you had the context of the sort of vector map overlaid on top of it. And then when you got to your view, maybe the data would finally catch up, because our servers were quite slow at the time.
Are you at any moment, like, because it seems like that's also, you end up working at Keyhole and then Google, and like, from what I can tell, exclusively on maps for like quite a long time. Did you miss part of the like video game and 3D rendering on the entertainment side at some point? I know you end up back at Niantic and doing that, but I wonder at some point, if I'm always curious, like, what pushed people to end up working on the things that they're working on, and what gets them into a specific project and then the projects that follow on.
Well, so one of the things in my time in Silicon Graphics was that, while we did have that Nintendo group sitting next to us, almost everything that my team built was not about gaming. It was about high-end scientific computing, computational fluid dynamics, automotive CAD modeling, and volumetric rendering. So we got to see many of the early high performance 3D graphics applications that eventually made it down to the PC 10 years later or 7 years later. But at the time, literally only our machines could do this. We had the fastest graphics in the world. And I think that experience of building a platform was, I think, the thing that most gratified me is, like, if you build something that is a platform and other people use it to do things, you get this sort of vicarious excitement of helping somebody succeed. But all you did was do the platform. And so OpenGL and this graphics hardware that we built allowed thousands of applications on silicon graphics machines to sort of change how engineering and product development and science was done. And what we built was this platform. And so I think I
Right.
really enjoyed building the platform. And 3D graphics is just visually pleasing. But there are many outlets besides entertainment. And so I think at that time through SGI, I got a strong desire to look at all the applications of 3D graphics.
I see. So Keyhole then gets acquired by Google. A lot of the work that is done in the team that worked at Keyhole ends up working on Google Maps and Google Earth that become just massive, huge projects. I mean, I think in terms of life-changing applications, Google Maps has got to be up there. And these projects evolved a lot. And I'm really curious on if I open Google Earth today. So, we're at the end of 2023, very end of the year. If I open Google Earth on my desktop today, how much do you think is still there from like the moment Keyhole got acquired, for example? Like I'm really curious how much software changes a lot, data changes a lot, but I'm really curious on maybe a philosophical aspect, like how much of the original projects is still in what I can open up today.
Well, it depends on which version of Google Earth you open. So the Google Earth Pro or the Windows or Macintosh binary is actually pretty static since about 2013 or 14. They've patched it and made sure they have any security bug fixes in, but as far as I know, they have not changed it much since then. So in many ways, that is a snapshot in time, and there's a few things that binary does that the web-based earth.google.com does not do.
Right.
But I would say that the data organization is very similar to what we originally designed. We found many optimizations when serving over time, and the PC binary I think reflects that. But this idea of vectors on top of raster and terrain data as sort of a separate stream, all that is as we designed it more or less when Keyhole was acquired by Google in 2004. There's obviously many new capabilities like Street View and the 3D building data that was developed. Street View, developed 06, 07, 08 and added to Earth and Maps, around that time. And the 3D buildings, we had two iterations of that. One of them was the sort of KML version coming out of SketchUp. And so SketchUp was this awesome modeling program that allowed people to create 3D buildings and even texture them. And many people created very nice 3D buildings and wanted to put them in Google Earth. We decided to buy the company SketchUp and really make that a thing, and modeled many sort of urban city cores manually with elbow grease to create a 3D building experience. And that lasted for 5 years until 2011 when we launched the 3D models generated from aerial imagery. And
so photogrammetry based.
Yeah, exactly.
That is still what you would see today on Google Maps as well. It's starting to show up there more and more. Right.
Yeah, I mean the combination of Google Maps and Google Earth, when we joined, there were two efforts at Google. There was the Maps effort and the Earth effort. And Lars and Jens Rasmussen and Brett Taylor, among others, were working on Google Maps, and we were working on Google Earth. And we eventually combined the teams. I would say we never fully successfully combined the products. There's no single product that is, everything for everyone. And I think part of it is that the capabilities are so diverse. You've seen all of the features and things that have been added to Maps, and many of the features in Google Earth are not in any of the combined products because, if you tried to stuff all of that into one app, it would explode. It would be unusable
Right.
by all of its users. As it is, I think, both products probably have more features than most users know what to do with. And if you read the press, Google Maps may have gone a bit far in the last few years with new capabilities. But at the
What do
time,
you mean by that? As in like too
it's
much?
it's too much. It's too complicated, and
Okay.
they're making changes in some cases gratuitously. There's definitely been some backlash against the changes in the rendering of Google Maps
Right. Yeah.
recently. But back in '04, Google had acquired a company called Where2,
Hmm.
Australia-based, and acquired Keyhole. And Where2 had originally built a PC-based, tile-based map. So they had a download that would then do maps. And I think Larry and Sergey asked them, no, make it web-based. And so they did a crash program and invented, a new way of rendering, pre-rendering effectively the map tiles, and effectively invented Ajax. The active JavaScript applications, and they when Google Maps came out in February of '05, it was a absolute revelation. It completely changed how everybody thought about maps, because they had grown. People had gotten used to MapQuest, and the first thing they found out with Google Maps is it is extremely fast, and if you drag it, you can just keep dragging it, and it will always have the data. You can zoom in, zoom out, and it's always got the data, and it looks good. It looks really good, and the trick was it was all pre-rendered, but that's fine. It was just serving map tiles out at as high a speed as Google's capable of, which is a pretty high speed.
Yeah. If anybody can probably do something fast, it would be Google. One
So
of the
that was a big
elements.
launch. Go ahead.
Sorry. Yeah. Yeah. I was reading, like, Bill's book is just fantastic resource to try to get a little bit of a understanding of what happened. I think he conveys the excitement that there was around the launch of both Maps, adding the satellite image later on, and then Google Earth. One of the things I found really interesting is this whole story, well, multiple stories of how people take borders very, very seriously. When where I am also, I think computer nerd is something that I could apply to myself as well. It's very tempting to get absorbed in the data, the engineering, the computer science, and trying to render things on a screen. But what people see on their screen, they don't see all the work. They see the end results, and people care very much about borders. Like, there's a really big importance on borders, and so when I think it was when Google Maps first starts, there's protests on basically like where the borders are. And from what I understood, it's not as out of Google picking a side. It's just you need a default, and someone's going to be unhappy with it. And I wanted to linger on that a little bit because it's, I think, a great example of when the real world quote meets technology and trying to build stuff, and then people actually using it and caring really deeply. Um, and so I'd be curious to know if you could walk me through a little bit of some of those examples and how that went, how you guys tried to solve some of that.
Well, I think the interesting challenge is that in the past, even when the internet was out, you had a map of a country, and that map was for that country, and how that was represented was for the people of that country, and so it was relatively simple to normalize to whatever the country itself expected its map to look like. But when you have a single map for the whole world that is shared among all viewers, you immediately get into this problem that different countries have different opinions about the maps. And, when Google Maps and then Google Earth became extremely popular, we very quickly became the single map that people argued over. In the past, there had probably been skirmishes for MapQuest or some other thing that was showing data, but we I think unified everybody's strong opinions about maps, and they expected if it their view to be shown in Google, if or they would not be happy, and our solution with Google Earth and showing disputed borders, um, labeling them as disputed borders, the dashed lines, I think was our attempt at this, and this addressed many of the situations because I think most countries accepted that borders were in dispute, and there is another opinion here. But if you wanted to do business in China or India, then it really mattered, how you drew the map, because their opinions, they were very much in denial of the other country's opinion, and so with Google Maps in particular, we did have this benefit of the fact that the domain maps.google.in for India was different than maps.google.com. And so you could serve a map customized to India or .cn to China that was, met the letter of the law there, but you would still end up at, if you went to google.com, you would get the disputed borders and you would get the one map that we tried to, answer all these questions. So for maps, you could serve slightly different maps for different countries and to do business there. For Google Earth, it was harder because it's pretty much one binary, so it was one answer.
And so how did you handle that? Because now you basically have multiple Google Maps. You have multiple maps that you just show to different people. And so everybody thinks there's one map, but there's kind of these multiple versions. But there is one place where you have to have a single one.
That's right. And we just, with Google Earth, we just fought it. And we said, hey, the borders are disputed. We're drawing the dashed lines. And,
right.
That's the way it goes. I think we eventually walked through every disputed border, some of which I think we were unaware of when we started, because we would get protests from very specific countries about borders in the Andes Mountains.
Yeah, because maps are also something that are dynamic in the sense that it's not just you have your map and it's going to be this case and it's never going to move ever again. I mean, there's the thing about satellite images, and you want recent satellite image. There's things where a road is blocked and now traffic is moved, but borders not as much anymore these days. But there've always been constant thing. There's never been something that's been fixed, and so I guess I didn't even think about it from the context of borders having to change. But that's also something where I don't know, like Crimea gets or Ukraine, and then do you change the border? That sounds like a really hard problem.
One of the border challenges that we had was that we took our national, international borders from the best data sets that we could find. We didn't author them ourselves. We would look for the references, and so our national borders around the world, were quite good, but there was a mistake in one of them, and there was a area of land on a river between Nicaragua and Costa Rica where we had drawn the border in the wrong place. And so Nicaragua said, we are going to take possession of this land. And so they put 25, 30 troops on this land. They invaded Costa Rican territory. And for 3 weeks, they went there and it said, because, the Google Maps has said this is our land. And it turns out that we had the wrong border data, and we had to correct it. And we did correct it, and they withdrew, not because of our correction, but they did in fact claim that they were using this map as their reference for why they own this piece of land. And Costa Rica was in a bit of a spot because they did not have a standing army, so there was not much they could do about it. So yes, borders matter, and maybe we were an excuse, but
yeah, it's not just polygons in a database. it's I don't know, it's just such a telling story because it's like from a data point of view, it's like one of the simplest things. It's lines. They're pretty complicated, but there isn't even that many of them. Like you can download the borders of the entire world at a pretty high resolution, and it's a file of maybe like 10 megabytes.
Yep.
It's not that big of a deal, but in terms of the data side, but the implications of that file are huge. And I don't know, I think sometimes I know I get bogged into like these really big computational problems, but some of the ones that matter are not even huge engineering ones. I don't know, that I find that very interesting.
Well, I mean, if you think about it, maps in general were funded for sort of two reasons: exploration and border disputes, right? The explorers, all those globes that we saw were trying to get an accurate depiction of the geography, but many of the maps were, who owns which property, whether it's a county, a city, or a country, and there had to be agreement on this, and it, especially when you get down to the finer grains, like when Google Maps adds city borders and property borders, we put in our best source for property border data, but immediately people would go, this is wrong, my neighbor's on my property and all this stuff. And it turns out that the plat maps that the county has have never been accurately digitized to the level where you can just drop them down on a map and not provoke at least some questions about accuracy.
Yeah, I think if you make it very easy to access as well, like if it's just somewhere on some hard drive and nobody knows about it, doesn't really matter. But as soon as the entire world can see it in 2 clicks, then it sort of matters.
Yeah, and that's to a degree what Google Maps and Earth did, is they brought all of this data that was hard to use and they put it in front of consumers who immediately started exploring it, and then discovered what we all eventually discovered, which is map data is deeply inaccurate. It's a very hard thing to map the world accurately, and the tolerance for error when nobody could check or very few people could check was much higher than when you put hundreds of millions of eyeballs over millions of hours on this data. They will find every mistake because somebody somewhere is standing next to the thing in question and says it's not there, or or you missed it. And in the grand scheme of things, that was, I think, the single biggest revelation we had at Google Maps was when we published Street View data. We sort of immediately got this backlash from people who said, look, your Street View picture says that the street name is this and the street number is that, and your map doesn't say that. What's up? And the reason was we were licensing data from TomTom at the time, and it was debatably one of the two best data sources available, but it wasn't very good. It had all of these errors, and that led us on our path of building our own maps.
I want to come back on, you mentioned there was historically two reasons to fund maps. I think those have changed a little bit. So let me ask you, this is a huge part of Bill's book, but I still want to ask it to you. Like, why did Google pay so much money, and still continues to, but like specifically early on, pay so much to build maps in Earth?
Google realized, that what people look for is valuable, right? Search matters because you have the intent of the user. If you know what you're looking for, then we can advertise things relative to what you're looking for and have much higher confidence about the quality of our ads, and therefore our ads are more valuable. People pay us more for the ads. So Google cared very much about what people looked for. And early on, Google realized that over 10% of searches were for local businesses and for locations. And the data they had at the time from the web crawl was not very good at all. And they realized, that canonical, accurate local data and map data was, fundamentally part of what people wanted answers for.
So that's something like I don't know, like coffee shop near me or a restaurant like Indian restaurant in whatever city you're in.
Where are the nearby schools? Uh, and also just people search for map data also. So local plus maps was a big component of Google searches, and the data they had in 2003 was not very good at all. They actually had started a project to try to aggregate and organize local data crawled from the web, and they discovered it wasn't great. And so this idea of going sort of the more canonical way of let's build a data set of local businesses, build a maps data set, and have accurate answers to these questions. They realized this in '04 and '05, and made eventually local and maps into these idea of one boxes or quick responses to searches, so they would provide the answers directly.
Yeah, the way I usually describe it is that Google Maps is basically just ads, but it's like ad support. It's like Google search, but just on a map. So like the whole business model of Google search, but so you get to know what people look for, and you can target ads. You can just, very simply boiling it down, it's the same thing on a map. What about Google Earth? Is it the same thing? Is it also just knowing what people look for? Because you search for different things.
Yeah, I would say that Google Earth as a standalone business model of a consumer product doesn't have a business model even today. It is still providing a service as part of Google that is clearly useful, but doesn't have a revenue path uh, on the consumer side that makes a lot of sense. And so I think they continue to support it because it is good, but I don't think it pays for itself directly. But Google Maps, I'm sure the advertising Google Maps generates revenue, but it probably doesn't pay for the maps by itself. But if you look at Google search, 10 to 20% of search results are now from that map data, from that same data. And the map on the search result clicks through to a Google map. And so I think the reason that Google invests so much in maps is they need to have the best answers to those questions, so users continue to come back and look there. And even whether those searches themselves monetize as well or not, they want to make sure that users don't leave their search engine.
Were you involved with the Google Earth Engine at any point? So a bit different, but this is more for scientific computing, but on the really processing of data. I know Rebecca Moore was a really big person involved in that, and it happens a little bit later. But I'm curious if you worked on any of it.
Oh yeah, I mean, I managed the team throughout the whole development of Google Earth Engine. So
Right.
Rebecca,
Okay.
Rebecca is an interesting story. I hired her as one of our first GIS data engineers in 2005. She was probably one of the first 2 or 3 hires that our team did once we joined Google. And so, initially she worked on all of the extra data layers that we had not managed, had not done well with on Google Earth. But eventually, she got connected with some folks who had this idea for a sort of scientific computing and ingesting all of the historical satellite imagery from Landsat. And also, she knew that the inside of Google was built around this sort of scalable multi-machine computational model, and so her, along with her team, built this very powerful compute engine that sort of had this initial data set, which was Landsat, and we were the first, I think, to make all of Landsat available all of the time. And we had them pull the tapes and basically make a copy of everything for us and ingested all of that into the system. And so, the initially, I think that was on the order of, was it 2009, 10, somewhere in there. We had the Brazilian rainforest sort of regression model. We could detect when rainforest was getting cut down and generate reports that could then be sent to the Brazilian police to catch illegal logging. And that was at the time, a very big deal for climate change because, of course, rainforest logging is 10 to 20% of all of CO2 emission reduction possibility. So that was the thing that put it on the map. But they also had thousands of other scientists trying many other things, because the advantage was you could write an algorithm on Google Earth Engine and run it across the entire planet. And one of my favorites is always like studying of river meandering, right? How do rivers move over time? Well, any one river is interesting and it produces pretty animation, but you can actually do systemic analysis of rivers across the entire planet and decide when and why a particular meander or change or loop closure happens, and the river goes on. And so I thought that was a very interesting systemic application of world data.
I think it's back to, like, we're used to seeing maybe one satellite image or one map, but the world actually moves and changes a lot. And it's a different time frame as well. But I really like showing people back to Google Earth. Like, there's you can go back in time. You can change the time series goes quite back. I mean, that's Landsat, so it's 1972 at the earliest.
Earlier.
Well, then it's not Landsat. It's probably like even earlier. But yeah,
do
you know what the earliest image?
Earlier data sources in Google Earth? Yes.
Yeah. So do you know actually what the earliest image that you could find on Google Earth is?
I was afraid you'd ask that. I know that there are some from
brought it up.
the 1940s. We ingested a bunch of World War II aerial imagery of San Francisco and Berlin and London. And so you can see those cities in the midst of World War II. And you can see the damage of the bombings in Berlin and the bombings in London. You can see warships parked in San Francisco and see what San Francisco looked like in the 1940s. And it's pretty cool. So where it was historical aerial imagery that we could get, we ingested it just like everything else. And so I know those three places at least have very old data, but I know there are other sources that were brought in as well.
That is in Google Earth today. Like, we can go.
Yep.
Okay, that's where I'm gonna have to go take a look at that. You were talking about earlier how one of the things that you liked was building these platforms, I think was the word that you used, for other people. Google Maps launched its API a little bit later that basically opens up a lot of these businesses that are location based. So you have your Stravas and your Zillow, and one of them is Uber, and you end up going kind of jumping on the other side of that and working at Uber for a little while. And I'd be curious to hear a little bit about your experience there, not building the map, but working on the map and kind of building on top of the map, and what that was like.
Yeah, so I mean, the Uber hired me because I think they realized that the map is sort of existential to Uber, right? The whole point of connecting the rider and the driver in an efficient manner is critical to their business, and so they had visualized on Google Maps, but for their routing, they could not afford, and Google didn't provide a high performance routing API that matched what Uber needed internally. And so we used map data to create this very high speed routing, because we needed to get routes from 8 different cars to you every few seconds to then successfully make the decision about which of those cars was going in the right direction at the right time, that was nearest, that would then say yes to picking you up. And we would have to do this, at huge volume. And so Uber was really focused on this routing problem. And they cared very much about accurate map data. And they also cared a lot about traffic data. And Google Maps traffic at the time was quite good, but in urban areas using Uber's own data, Uber actually had better traffic data. And so in some ways, it's a little bit self-fulfilling. So the combination of Uber's traffic feeds from its drivers, as well as this sort of high performance routing, were where the main focus is in the maps team and just improving the maps quality. Because the other thing that Uber cared a lot about was finding locations. Like if you're going to a destination, we had to know the restaurant and know where it was and take you to exactly the right place. And so Uber also cared very much about the local POI data and the accuracy of it. And Uber licensed data from Foursquare and others, but again, quality wasn't great. So figuring out how to improve the quality of that was pretty critical to their business.
Yeah, I guess I didn't even think about that, because most of what Google, if you're asking to go somewhere, it's your phone knows where you are. You say you want to go to the restaurant. That's kind of it. But then Uber has to do that multiple times because it's trying to figure out which driver is going to pick you up. So it has to pretty quickly, because otherwise you get, like, usually when you're asking for an Uber, you're kind of in a rush, or like you just want it to work. You're not sitting at your desktop and trying to plan your trip next week or whatever. So there's also that time component. What was it like to work with the tools that you had helped develop? Because there's also that component.
I mean, I think as a customer, the APIs, worked very well. As a customer, the pricing was a challenge. I mean, at the levels that,
Right.
that Uber was using, it was material to Uber's business to figure out what the price was that we could afford to pay, and so the part of what we had to do was, take the heavy use cases and solve them ourselves, because we couldn't afford to pay Google for all of that. And so, we greatly appreciated the accuracy of their POI search, and I think used that as our primary for quite a while. But even that became too expensive, and I think Uber ended up with its own POI. Although Uber has changed back and forth, I think after I left, they went back and did a deal with Google a couple years later, is my understanding.
Yeah, you were there from 2015 to 2017. So that was, yeah. Well, things have probably changed quite a lot since then as well.
One of the other things you could ask me about is the self-driving stuff.
That's some of the work that you were involved at Uber as well.
Yes.
Because I know that Google started some of its work on self-driving as well. And so, yeah, I'd be curious what your involvement was on there.
So there's two things. One, at Google in 2008 or 9, Sebastian Thrun and his team started Waymo, or Chauffeur as it was called back then, in my group for about 3 months. But it immediately jumped off into what was the beginning of Google X and this whole separate separate projects area that I guess is now the Alphabets that Larry likes. And we did not work closely with that team after they jumped. Like, they had their own map story and took care of things themselves.
And so what point is that, by the way?
So that would have been 2009. So the same team that helped start the Ground Truth project at Google Maps, which was Sebastian Thrun and others, after the project Ground Truth was moving and actually doing quite well. Sebastian Thrun is a sort of self-driving expert, and decided to go back to working on that, and started his project in my group, but eventually moved over.
And yeah, I think Ground Truth also was I just want to linger on that. I wasn't aware of that project before reading Bill's book, but it's actually an enormous undertaking of trying to map basically every road, every sign, everything from Street View, because the pricing from some of the data licensors was just getting too high. And so starting this whole project that I think maybe consumers haven't seen as much directly. Like you see the impact when there's navigation and things like that, but it's not as visible as you can go to Google Maps. Yet there's a website that you can go to and see. So there's a whole project that is enormous. I just wanted to add a little bit of context there. And so you did you do any of the self-driving work after Waymo becomes its own thing?
So at Google, I did not, I actually got to drive in a Waymo car, or was driven in a Waymo car back in 2012, and was actually pretty impressed with the capabilities back then. But that was probably the biggest intersection I had with them until uh, I left and joined Uber and led their self-driving team for about a year. And what I learned is that self-driving needs maps even more than regular drivers need maps. And the challenge is that they need a different map. Um, the precise location of everything, whether it's curbs and streetlights and stop lines and, the buildings, all of this matters, but really what matters is where is the car? And the GPS is just nowhere near good enough. If you want to position your car within the lane, or making a left turn, staying aligned, you need to know exactly where your car is every minute, every moment, and you need to know within a few centimeters where it is. And so, all reasonable self-driving car companies build up this very high quality 3D map using LiDAR data and point clouds, and they have the usual Google Maps, canonical attributes as well, but this geometric model is used for visual positioning, or positioning, and this is how cars know where they are in the world. And if you think about it, it has to work. You need this no matter what, because in tunnels and in parking garages, you don't see the GPS anyway, so you have really no idea. But if you have an accurate map, you can find yourself even in those locations. And so, building that map taught me a lot about the sort of very high level accuracy of maps, and also that when you get to the centimeter level, there isn't a single WGS 84 map of the world. The accuracy of these maps has to be higher than anything else you've seen, and also struggles with things like tectonic shift. So the several centimeters a year that you see shifting in San Francisco, that the various state planes take care of, if you know what year you are not resolvable in WGS 84. You just have the now. And so if you have these self-driving car maps that care about the centimeters, they focused more on being relatively accurate than on being globally accurate. And once the
Right.
car
Yeah,
knew
yeah.
where it was, it knew where the street was, and if it drove far enough, it would shift to another map that was also locally accurate. And so tiling the world into these locally accurate maps was, I think, the revelation I had from working on self-driving cars.
Yeah, there's kind of this adage like, difference in amount is just a difference in kind, and it feels like that's a little bit what's happening. Is um, you're still mapping, like it's still pixels and points and lines, but the accuracy is so high that it ends up being quite different. I think I hadn't fully internalized as well that like one of the biggest difference with self-driving is compared to that just having it on your phone is that your phone is just listening. It's not trying to map the world around it. It's just listening. This is where the GPS, um, it basically receives GPS. It knows where it is. It's not trying to map its surroundings. There's maybe the gyroscope that tells you which direction you are, but that's it. And a car has to map its surroundings more than it receives data.
The more accurate your map, the more you care about change. And so self-driving cars care deeply about orange cones and construction and temporary objects that could be blocking the road. And so a car, that's driving down the road is not just using the map, but they're also generating the changes to the map so that the next car that comes by will know, what has changed. That makes for a much, much harder mapping problem.
Yeah, where do you think we are in self-driving today? I think like if you are just someone that follows, you know, tech development, self-driving is something that's been heard about for a while, but it doesn't feel like it's getting quite there yet. It feels like there's this asymptotic. I think you get what I mean. Like we're kind of getting to a point where it's not these huge step changes; it's these like very incremental changes. I'm curious. You've worked on it. Where do you think we are today?
Well, I mean, I think you're right that it's an asymptotically approaching perfection.
That's much better
And
than how I said it.
and what's interesting is the bar is not as high as you might think. The average, let's see, get these numbers right. The average police reported accident in the United States is every 100,000 miles. And the average injury is in the, I think, low millions of miles. The average death is every 100 million driven miles. And so from the opportunity to see, risky, dangerous situations, you would have to collect 100 million miles of data to perhaps see one death-causing data set to help train your system. So figuring out how to build a system just from collected data and just trained on collected data is not good enough. You basically have to simulate all these possible crazy situations and figure out how to get your software to address those. The other side of this is that the quality of American driver, at least, all those numbers are for the average American driver. The teenager with their license is 3 times worse than that. And so, and they're allowed on the road, and they do cause more than their share of accidents and injuries. But I think the problem with computers is they're probably already materially better than humans in most cases, or possibly even all cases. But any accident caused by a computer or where a computer is involved changes the complexion of how people approach it. And so, I think the computer, self-driving has to be better, materially better than human, and it has to do it long enough and well enough that people just concede it. And so Waymo continues to be the gold standard, right? They're driving in Phoenix and San Francisco and Austin and Detroit, maybe. They are taking paying passengers in Phoenix. You can pull out your Waymo app and ask to get picked up, and works fine. And if you look at Waymo's track record, they have done quite well. The many other competitors, started out behind because Waymo really did start first. But they've also struggled probably with overinvesting. Uber overinvested in some areas. And Volkswagen and Mercedes have both struggled. So I think that the alternatives aren't really there. So Cruise really was second best, and it's really unfortunate that this accident has kind of crippled them. It was not a good situation. I suspect a human in the same situation would have not done any better, but it doesn't matter. It's GM was unhappy with how things were handled internally and has now fired a bunch of people and cut back on spending, which means that Cruise is not going to move as quickly as I would have hoped. Tesla is the other one, and unfortunately, Tesla just has the wrong philosophy. Elon is delusional and thinking you don't need a map to do self-driving, and I was a early adopter of the autopilot in 2014, and it scared the hell out of me back then. But autopilot today works most of the time pretty well on a highway, but it's not even remotely close to safe enough in cities. And they say you're supposed to keep your hands on the wheel and keep watching, but the danger is that humans who are supposed to be watching a computer do not watch it very closely, and so the computer has to be really good at its job. And Tesla, unfortunately, has demonstrated that autopilot's just not there yet.
How long do you think it is until we have just people don't drive anymore?
I would say probably 20 years before, it's almost illegal to drive. I'm sure it will depend on location. And again, it will be city centers, urban areas first, and also trucks on highways. Um, yeah, because those are the too high volume and also debatably easier to solve. The highway one, there's a lot of truck companies trying to do self driving. It's interesting that the trucks have not typically actually even well supported cruise control because they're worried about humans becoming inattentive. But their self-driving trucks are, I think, a strong opportunity, especially in the United States, where truck drivers are aging out, and it's their huge demand, not enough people, and the trucking industry is growing. So I think we'll see self-driving trucks on highways, which is an easier problem than sort of end-to-end self-driving, similar to autopilot on Tesla.
I always wonder if it. This is probably an incredibly naive take, but I'm in Europe, and I think a lot of the transport happens by train here more, and I've always been surprised that like for uh, long haul like truck driving, I feel like trains already solve the problem. Is it like a situation where we've been so focused on the technical problem at hand, like the cool problem as well? Because like self-driving is a very cool problem to be working on. And trains are just a kind of boring thing. And so we haven't gone for it.
Well, there's also self-driving train efforts as well. They're trying to save money
It's
on the
probably a lot
the
easier
pilots.
though. Again, very naive.
But so so in Europe certainly a much larger percentage of things are carried by train, and that's partially because there are train tracks everywhere, including some amount of high speed rail, which solves a different category. In the United States, we have what rail we're going to have. Building rail at scale is too much of a political problem, and so I think we are stuck with where we're at. Um, I mean, the other thing, trucks are still needed for the last n miles, right? I mean, trains do not go everywhere, and not all factories and production and consumption is on a train track, and so you still need to transport from location to. But for long haul trucking, the United States will care very much because the trains, we're not going to be laying down national tracks in the U.S. in any material amounts. Maybe we'll do a few, but if you look at the high speed rail project in California, it's a complete cluster. They're just not going to get it built because it's now 80 to 100 billion dollars, and there's too much of this not in my backyard.
So it's like a technological solution to a political problem.
Yeah. And
Interesting.
roads are historically something the United States has spent money on and takes care of and
Yeah, yeah, yeah.
works
Yeah,
very
yeah.
well, right? I mean,
Fair
yeah,
enough.
in many ways, roads are what built the United States, right? The President Eisenhower in the 1950s and the interstate highway system fundamentally made this country successful by allowing for goods and services to move, at relatively high speeds, practically anywhere. And I think we got attached to that romantic notion, and trains trains did not fulfill that.
This is something that's very interesting to see, like how different parts of the world have made different bets. Um,
It's the timing of when technology is adopted. If you look at it, the number of wired phones in India is under 10 or 20%. The number of cell phones in India is just shocking. And they are moving their business to the cell phone. And the US doesn't have it to that degree. Both China and India are taking, I think, cell phone commerce and business much more seriously than the United States and Europe. And I worry that both of these older civilizations are going to get steamrolled by innovation in the business and technology that India and China are going to do.
there's two more things that I want to go on. The first one is I want to go to some of your more recent work, which is working with John again at Niantic. And I'd be curious to know, what are you doing now at Niantic. So just very quick introduction, like Niantic is the company I think most people would know for Pokemon Go, which is this tiny little app um, that had a pretty big deal. And so I'm curious, yeah, back to working with a lot, I think quite a bit of the team that was originally on some of the Google Maps. I'm curious to know, yeah, if you could describe some of the work that you're doing there now.
I mean, it's interesting because there is a through line that makes complete sense, which is I'm working on augmented reality, and augmented reality, to successfully augment reality, you need a very good map of reality. Virtual reality is interesting, and but augmented reality is harder, and the glasses are sort of not as advanced and not in high volume yet. But we're using cell phones today to prove out a lot of the technologies that are going to be needed for glasses, augmented reality in the future. And so Pokemon Go had augmented reality experiences as part of the game in 2016 and became very famous for that. But that was a very small piece of the problem that we're addressing today. Um, the thing that we're building that is very similar to the rest of this conversation is a visual positioning system. Much like self-driving cars need to know where they are in the world so they can be precise within their lane, we are doing the same thing for human scale pedestrian locations. And so all of the Pokestops, in the world are being mapped by our players, or collecting data by our players, that we then turn into these visual positioning maps that allow us to tell you exactly where you're standing relative to this location. So we're building this centimeter level accurate positioning system for a relatively narrow set of places that allows for game experiences and game content to be placed in the world and have it be in exactly the same place that the time a new player visits that location and sees the content that you left there. So this idea of building maps from uh, um, input pictures, in this case video, is a very large focus for my group.
So back to building a platform for the next generation of computing, and spatial computing is a word that's kind of come up again. So in that, where do you see that going over the next few years? Because it seems like you're hinting at there's some hardware that we don't have just yet, but we're building the tooling. That's kind of what I'm hearing from what you're saying. So, okay, let's roll the clock a little bit. What does that look like in the next few years? Kind of what are you hoping for, and or what do you think is coming?
Well, I think there's going to be a transition to glasses from the phone, just generically. Carrying your phone around and looking at it is annoying, and if you could wear glasses and see all the same data, um, it would be a less obtrusive experience. And the challenge is a little bit on input, but ignoring that. Um, so people will be wearing glasses just to look at the content of their phone, but that's not sort of geospatial. The interesting part is, can the glasses know where you are in the world and recognize things in the distance and know how, what you're looking at, label it if necessary, if that's interesting, or recognize that this is a building surface off in the distance and I can put other information on it so that you can see the world augmented with your information on that face of that building. For example, your email could be read on the face of the building, and it turns out that's much better than having it bounce around as you move your head, um, so because you focus in the wrong place. So if you know enough about the world that you can place content upon it and that content stays locked to the physical location, that's a very powerful experience. And so glasses are going to need this. And lidar on the glasses, or at least on these headsets, they can map maybe 5 meters, they can map this room, but they can't map the street around them, they can't map the buildings in the distance. And so you need a very high quality, accurate map of things in the distance, and to be able to localize yourself precisely right now, right here, so that relative to where I'm standing, I have an exactly accurate opinion about where that building is.
I'm curious what you think about some of the efforts that Meta has been doing in that sense, and then Apple with their new, yet to be released at the time we're having this conversation, Vision Pro.
So I think the Quest 3 and the Vision Pro are both very interesting prototyping devices for augmented reality because they are mixed reality. And they've added these cameras that give you a good illusion of looking through them and seeing what you would see in the real world, but it's all rendered on a screen. And in some ways, it's easier from a software perspective because what the camera sees and then what you draw on top of it are perfectly in sync. Um, Whereas, if it's a glasses display, then photons move and heads move at different velocities. But both of those are excellent devices. I have a Quest 3 right here that I'm testing. The Vision Pro, from what I've read and from what people on my team have seen, is even more impressive from a visual quality perspective. But these are mostly indoor devices. There's a few people who will be crazy enough to wear them outdoors, but they're not going to.
Yeah, that's going to happen.
It's not going to be a real outdoor device. But they allow us to develop outdoor apps and prove out outdoor use cases today that will eventually be on the glasses of tomorrow.
In Bill's book, there's a whole section where John receives an email from Steve Jobs, and they this is 2006, I think, just before the iPhone comes out, in trying to get Google Maps on the iPhone, which becomes one of the really big selling point for now. You can have this map with you that tells you where you are. It's not just having the map with you, but it kind of, now you're on the map as well. Do you think we can have another version of that with maps, but also just AR glasses? Do you think there's going to be another iPhone moment like that, or is it going to be more gradual?
I think the transition is going to be more, people are going to adopt glasses to replace their phone display. And the phone display at the moment is, mostly consuming content that is, divorced from the real world. It's your videos, your emails, your messages, your stream, whatever it is. But once they're on your head, then there's an opportunity to have all of this additional geo relevant information displayed as well. And the challenge will be, like with all devices, is managing attention. How frequently can you show it? Is it you don't want to distract people. If you show it all the time, you'll just drive people crazy and they'll turn it off. So
I see.
Making a usable interface in glasses is, I think, going to be a ongoing long-term challenge. And VR is a different use case. In VR, you're basically defining the experience. Every pixel you see is part of the experience that you're there. But in AR, most of the time, I'm living real life. I have people I want to talk to and things I want to see and steps that I want to make sure I don't trip over. And so the real world has to always be there. And it's nice that I can have extra information, but I think we will be making that transition pretty quickly because these phones really are bricks. I mean, they're heavy, they're annoying, they're distracting. You look down all the time. I think we can get to a place where we look up more often.
I like that. That's a nice. I was looking at Niantic's website, and I think one of the values is just getting people to go outdoors again. I thought, I don't think I've seen a company have a mission statement like something like that. I think it's a pretty unique thing to have.
I mean, I'll second that and say that it's not just something we put on our website. It's fundamental to our game design, and we make actual business choices that are optimal for the goal and not for our financials. I mean, we think that these games make most sense when played outdoors, moving around, traveling, usually walking, and being able to get from place to place and motivating you to go from place to place. And so the games are designed around that.
Do you have examples of like when uh, decisions like that were made?
A good example is that Pokemon Go has always had that mission statement, but during COVID we had to change it slightly because COVID, for a while was telling people don't go outside, which it turns out was the wrong advice. Outside is fine. It's the indoors with people that's dangerous. But in any case, for a while people were kept indoors, and so we had to add gameplay that was easier to do indoors at home.
I didn't even think about that.
We stretched the radius of certain things happening. We created this thing called a remote raid pass. And this led to some game decisions, that, were, you know, enjoyable for a couch potato, but not good for the game overall. And I think in 2023, we unwound one of the harder decisions there, which was the usage and cost of the remote raid pass, and that led to controversy, and people were unhappy. But it was causing, it's not setting the right motivations in the game. We want people to go outside to go do raids locally, and we think that that's an important part of the experience. And so that was definitely a difficult decision, holding this mission statement above financial rewards.
Also, changing gears, a topic that I wanted to ask you about is you've been doing some teaching for a little bit at the University of Kansas, and so I think you've been there for a little while. I know that you've done a course teaching startups, basically like how to start a company in high growth tech. There's actually some of your talks that are available online, which is pretty cool. But that's quite different from building. Like teaching is something quite different. And I wanted to ask you what drove you to do some of the teaching and what you found in it.
So, I mean, I've always sort of had great gratitude for what I learned at the University of Kansas. The courses I took, the final projects I had were effectively a perfect preparation for my career. And I've always wanted to get back in some form. And when I came back to Lawrence, I had this opportunity to teach, mostly guest lecturing at existing classes in computer science and engineering and law and business. But the startup school in particular, I I want folks in students in the university and also in the state of Kansas to do more startups. Like Silicon Valley is a very special place. I think some of that is spreading now to other places. Perhaps better than it was 10 years ago, but there's still not enough technology startups outside of Silicon Valley. And so I'm very tied into the startup community in the state of Kansas and in Kansas City. And I would like to see more of it there. And so I thought that introducing these students to what it means to create a startup company and what it would mean to work for a startup company as opposed to one of the big established ones would hopefully get more of these students to do that. And I've gotten a lot of good feedback from former students who've now either started companies or are working for startups because of the class.
Why do you think it's important? I want to dig on that a little bit more. Why is it important to have startups and companies started in other places than the Bay Area?
The biggest companies in the world are these technology companies. 20 years ago, 30 years ago, that wasn't true. But if you look at the top 10, 7 or 8 are now high-tech companies that were formed mostly in Silicon Valley or Seattle. And the impact of these companies, the big companies now is sure job creation. One of the quotes I have is that the net jobs created by existing companies in the United States is zero. The only new jobs net that are created are when startups happen, because big companies rise, big companies fall. Some of them die, some of them grow. That all washes out. The only new jobs come from these startups. And if you don't have startups, you're going to either net zero or shrink. And so if for the economy of the state of Kansas, we need startups. We need, whether they're technology startups or not, but high tech startups have this advantage of they can scale and bring in larger revenue, employ more people more efficiently than many other industries. And in many cases, they're solving problems that actually save the entire society cost. They reduce the costs, and by increasing capabilities in one dimension or another. And I believe that we need more of that, and I need people to think about that when they're creating companies. Because yes, you could start a restaurant, but it'll never be huge. Statistically, 99.9% of them never be huge. But you could start a company that solves a major problem that changes how people act, and that's a powerful capability, powerful feeling.
What do you think about remote work? Over the past, we talked about COVID, and in that ability to, that kind of pushed people to work, well, like you and me, that work on a laptop, basically, to work differently, work remotely. And I'm asking because, like, when I'm reading Bill's book, again, back to that, there's a lot of moments where there's interactions between people at different moments. Bill goes on runs with John Hankey a lot. There's meetings. There's a lot that happens in person, and we've changed pretty rapidly for a lot of people how we work. And I'm very curious, as you've worked at some of these companies, you've built a lot of these. What is, maybe some of the advice that you give to people? Do you tell them to do it in person, remote? Doesn't matter. I'm curious what you think about it.
That's a very complicated question. It is, I think one of the advantages of COVID is that it was a huge experiment in change. And, I always think of all of the data that we collect about humanity and finances and activities and so forth. A lot of that data, we imply meaning from it. But until COVID, we didn't really understand what variables were, dependent on each other, and what variables were independent, and what variables just didn't matter at all. And, it turned out that many things that we measured weren't really accurate, and COVID proved it by, all this change happening and this metric not changing. Work is a complicated one. That we were able to maintain productivity during COVID, even though most people didn't work in the office at all, is pretty amazing. I think that the push to go back to the office has a lot of reasons for it. I think as I've gone back, I work in Kansas, which is effectively a remote job. Most of my team, almost all of my team, is not in Lawrence. But when I go meet with them, it is absolutely clear that in-person meetings are very powerful. They, instead of 30 minutes on the calendar, it's 3 minutes and done. And you can then hop to the next person and do 3 minutes and done. You can achieve a day's worth of meetings in an hour, because you don't need to schedule and organize and so forth. So there are huge advantages to being, in the same office, in the same room, sometimes with folks, or have meetings with them. But I think there's a set of people that, are going to live in a place that is not convenient to your company, and you still need them. And so, our company has a, chunk of workers who are remote, some like myself. And then we have a very strong office culture in San Francisco, Seattle, Sunnyvale, Palo Alto, Tokyo, London. And getting folks in the office at least 2 or 3 days a week is very important to Niantic. And I see the benefits of it, but I also see that there are people that we would not be successful if we didn't have them. And there are people that live in San Diego or in Oxford or Germany. And so we still need, we need both. But I think that COVID was able to prove that you can accomplish a lot in a pure remote environment. The question really now is, if you can go either way, which one's more efficient? And I think it really depends on where people live and how you build your company. And if you can build it from arbitrary, anybody, then build it locally, build it in an office, and it'll probably work pretty well. But if you have unique requirements and skill sets, and you want the best of something, then you may have to deal with remote work and just figure out how to work around the challenges, which is kind of having your cake and eating it too.
What do you recommend to some of the students that you've had?
In general, I have many sort of pithy recommendations. I think I like computer science and mechanical engineering because effectively you can work on anything. Everybody needs software and hardware, and you have a personal passion in your life. Yours is maps, mine is maps, and I get to work on maps all the time as a computer scientist. Because I'm a computer scientist, I can build software that makes maps. And whatever your passion is, music, law, sports, whatever, everybody needs software. And so you can take software, apply it to your passion, have a great career. And if at some point you discover a new passion, that suddenly medicine matters and health matters and cancer research matters, you can take your skill set and move it over and work on that topic and make a big impact on that industry as well. And so I really believe that having computer science is a tool, and everybody needs it.
I think this is a nice place to start rounding it off. I like finishing by asking for a book and a podcast recommendation. And there's mainly two reasons for that. One is I think it's just another way to learn a little bit about people. And the second is that these still are pretty much word of mouth. That's how they travel a lot. There's a few recommendations for them, but it's still mostly from word of mouth. And so I'd be curious if there's a book that you've read that you think people should read, and it doesn't have to be about anything that we talked about. And then if you listen to any podcasts, well, you actually told me you didn't, but if there is any that you know about, you think are nice.
So I almost exclusively read science fiction. So I have a spreadsheet with my top 40 books, and one that is well known in science fiction, but probably not well known elsewhere, is the three-body problem, which is written by a Chinese man named Shishan Liu, I believe, and they're making a series about it, which is, I think it's Netflix. I'm not sure if he's putting it out, but it's a 3-book series. It is arguably one of the best science fiction books ever. It's fascinating. It's written by mainland China person describing an alternative mainland China universe that has some criticism of the government. It's very carefully written to get away with criticizing a variation of a government that doesn't quite exist. And apparently the government let him write it. So that was impressive, but the whole premise and the whole story is very good. So I would recommend that. And I do listen to one podcast, which is Marketplace with Kai Risdall, which is an American business program that I think is just extremely approachable and very good daily updates on business, but very in-depth studies of particular sort of esoterica in finance and business. And I would definitely strongly recommend that.
Thanks. Brian, thank you very much for spending some of your valuable time with me. I really appreciate the conversation. Learned a lot. This was great. Thank you so much. Hey, thank you so much for listening to this conversation. I wanted to take a moment to thank the sponsor of this video, but also all the people who financially support me on Patreon. If everything goes well, these conversations should feel and sound seamless and effortless, but there's a lot of work that goes behind the scenes. I try to research and prepare these as much as I can to know who these people are and what makes them interesting and what would lead to a good conversation. I'm incredibly thankful to all the people who support my work on Patreon, meaning I can do a little bit more of it. This podcast started out as a way to learn more about the people in this industry, but I've also started making educational content on another YouTube channel that I'll put a link to in the show notes. And I want to make more content explaining how satellite images and maps work to a broader audience, as well as continuing to research the guests for these podcast episodes. So if you value the work that I do, I'd like to ask you to please consider supporting my work on Patreon. There's also some behind the scenes of how this podcast is done and some of the work that I'm doing for these educational videos if you want to learn more about how I do all of this. Either way, thank you so much for all of your attention and your time. I really appreciate it, and I hope you get value from these conversations. Thanks.